Okay, so for our first lesson today, here's problem number 1. As mentioned, we have modified the equation from that one where we had to do box. You do not have to do box. Okay, so using the following figure, calculate the area and perimeter. Okay, so I know that I'm going to have to move from the screen. So to get all my numbers, I know the first thing I'm going to do, and you're welcome to copy as I'm doing this, is we're dealing with the triangle. And so the first thing you're going to want to do is go to your gold sheet, and it's base times height divided by 2. We talked about perimeter, and that's part B. So I'm going to go to my triangle and set this up before I move it off the screen. But we have, I'm going to count, 1, 2, 3, 4, 5, 6 from A to B. And from B to C, I have 1, 2, 3, 4. Okay? So I'm going to take those numbers. This is my base, that's my height. Okay, and we're going to figure out the area. So I'm going to go over here to part A. Part A, area is base times height divided by 2. The base is 6. The height is 4 divided by 2. I get 24 divided by 2. I get 12 units squared. It does say to round to the nearest tenth, but there are no decimals to deal with on this one. Okay, part B. Find the perimeter of the figure to the nearest tenth. Okay, perimeter, let me write this out. Perimeter is add up all sides, add up all lengths. Okay, so if we look back at the picture, we know that we have 6, we know that we have 4, but we do not have A to C. Okay, A to C is called the hypotenuse, and we use C to resemble what the variable is going to be there. Okay, do you guys remember how to solve for C when you have a right triangle? Okay, C equals square root of A squared plus B squared. Okay, so here we go. I'm going to go down here. I'm going to put perimeter for this triangle today is a 4 plus a 6. Does everybody see where I got the 4 and the 6? And then I'm going to add the C, and that's a hypotenuse. How do I get C? We go C equals square root of A squared plus B squared. Square root A squared. You can take any one of these numbers. It doesn't matter. I'm going to start with the 4 squared. The other one is the 6 squared. So if you've been wondering all this time where we're getting those numbers, it's the sides of your triangle. When we plug it in to the square root, we have 16 plus 36, which comes out to square root of 52, which comes out to 7.211. Now pay attention to where I'm going to box this in, if you don't mind doing that, to the nearest tenth. So you're going to take a look at the following number here. Okay, and I'm going to use a different color pen to point out. The tenth is the first spot after the decimal. Okay, so we have to determine if he's going to change. We look here, the guy behind him. If he is a 5 or greater than 5, okay, then we know that we're going to increase 2. So we have 7.2. Because that's a 1, 2 is not going to change. So my perimeter is 7.2, and it's units. Okay, we're not using feet or anything, or feet or miles or anything. Okay, so far I'm going to have the area. I'm going to rewrite it, 12 units squared. I'm going to box that in, which is a really good habit when you're taking any exam or quiz. The more answers I can find, the more credit I can give you. Okay, so now we're going to go off to part C and D. Part C says, suppose that the figure was dilated, so I'm going to underline the word dilated, by a scale factor of 4. So what's important here is the scale factor 4. Find the area of the new figure. So what we've done is we're going to enlarge our triangle. And we know that there's a special formula for that. Okay, and so basically I'm going to put The area of this new dilated is going to be the area of original. Where's the original coming from, class? Part A? Yep. Okay, so that's what we mean by original. And then we're going to multiply it by the scale factor. And I'm not going to use abbreviations because I worry students out there won't know what SF stands for. Scale factors. In this one, when we're finding the new area, you square the scale factor. Okay, so A original is this 12 units. So I'm going to plug in 12, and I'm going to multiply it by the scale factor, which is 4. So I'm going to go over here to the side to make sure you know that the scale factor is 4. Very significant. Okay, so please pay attention what your scale factor is. I'm going to plug that 4 right here. Okay, so the 12 comes from part A, and then the 4 comes from here. Okay, so we go ahead and multiply that out, and that is going to be a 12 times a 16, or you could just use your calculator. Okay, and you should get 192 units squared. Okay, so there's your new area, 192 units squared. Let's go on to part D. Perimeter is very similar. Again, I'm going to highlight that the scale factor is 4. They want to find the perimeter of the new figure. Okay, so we take the original, so this is going to be the new perimeter. You take the original perimeter, and where is that coming from? Part B. Very good. Okay, it's that 7.2 that we got earlier. And we're going to multiply it by the scale factor. And if it's okay with you, I'm going to abbreviate it this time. Okay? So, P original is 7.2. The scale factor happens to be the same. Okay, so 7.2 times 7. Did I do that right? Should be 17.2, right? 17.2. Can you go back to part B? That should be 17.21, and you should have 17.2 units. So I apologize for that. Okay. All right. 7.2 was the C. The perimeter is 7.2. 7.2, let me go back, was perimeter is equal to 4 plus 6 plus the 7.2. And that's how you get 17.2 units. Okay? So my bad on that. Okay, so let's go back over here, and this should be 17.2 multiplied by 4, and you should get 68.8 units. And that's P new. Okay, so I'm going to square that in. So let's summarize. Part A is 12. Part B is 17.2 units. Okay, Part C is 192 units squared, and Part D is 68.8 units. Okay. So let's go ahead and go to our cube, number 6. Okay. So a cube below has a side length of 6 centimeters and its density is 1.6 grams per centimeter. Okay, so this is a density problem. The first thing they're going to prompt you, so you don't have to think about what you need to do, just follow the questions. What is the volume of the cube? Because some of you already have that memorized in your head. Well, actually, number 2, I'm skipping. I apologize. Number 2. Okay, I have the single sheet, so I skip. So part 2, a landscaping company is estimating the cost to seed a client's lawn. A diagram of the lawn is shown below. Okay, seed costs $250. So what's really significant here is the $250. Okay, so when we do the cost, okay, we're gonna use that. Okay, so you go to your diagram, and this particular one's like a puzzle. Okay, and you're going to want to look for the biggest pieces that you can use. Okay, so I'm going to grab my ruler, and I'm going to come in here, and I realize that this is one triangle I want to use. Okay, and the other triangle I'm going to use is this little guy down here. And what's left, really nicely, you'll see this rectangle. So I'm going to number them as best I can. I'm going to number this little guy number 1. I'm going to name this triangle number 2, and the rectangle we will name number 3. Why? Because the goal here is to add up the area of all these 3. When you see this type of problem, they're asking for the area. Nowhere in here does it say look for area, does it? So you on your own are going to figure out what is the area of the lawn. Nowhere did they ask you that, did they? Okay, so over here, I'm going to break it up into 3 parts. An area of number 1 is a triangle, so I know I'm going to use base times height divided by 2. Okay, and base times height divided by 2. And he has a base of 2 here, if you're wondering where I'm getting that here, and then a height of 2. So we're going to put 2 times 2 divided by 2, which is 4 divided by 2, which is 2. And we're dealing with feet, so I'm going to put feet squared. I'm now going to do the area of the other triangle. You guys know what the base is of this one? What is it? 6. And what's the height? 4. Okay? So the base is, I'm counting the little blocks, 1, 2, 3, 4, 5, 6, and here we're counting 1, 2, 3, 4. So again, same formula. Okay, if not, use your gold sheet. All right, so 4 times 6 divided by 2 is 24 divided by 2, which is 12 feet squared. Okay, and finally we just have one more, area 3. And that's a rectangle, so you cannot use base times height divided by 2. What are you going to use? Yeah, length times width. Okay, so we got to go back to our picture and take a look at what our length is. So I'm going to count. Ready? 1, 2, 3, 4, 5, 6. And the height or the width is 3. So I have a 6 by 3. 6 times 3, which is 18 feet squared. Okay? Now, I hope you know what you're going to do next. What are you going to do with all that work? Add them up? You're right. Okay? Because I got to get the whole lawn. This is a lawn, if you're wondering. Okay? And they want to know how much seed to get for this lawn. Okay? So, and I'm going to go ahead and put lawn, so you know that that's what we're doing. Area of the lawn. Okay, is equal to A1 plus A2 plus A3. And I'm going to plug in those numbers. 2 plus 12 plus 18. And you should get 32 feet squared. Area of the lawn. Okay, so you got one part done. Okay, the second part, it's asking you how much will it cost. Okay, cost is basically taking the area you just discovered and multiplying it by the 250. So how much is it going to cost for the seed? How much is it going to cost for the seed? I'm going to take 32 and multiply it by $2.50. Okay, and you should get $80. Okay, so that's going to be charged to your fancy credit card, $80. All right, let's go on to number 3. We covered this on Thursday and Friday. A county has an area of 63 square miles, so we want that number. If the population density, and I use short population density, is 365 people per square mile, so if you wanted to know how to write that, when they say square mile, it's mile squared, basically. What is the population? So please, please, please tomorrow read what they're asking for, okay? In this one, they're asking for the population. Okay? Well, the formula for population density was as follows. Population density. Okay, and I will write this one up on the board. I will not write what population is. You guys need to do that on your own. I will write this one. Population density is the number of people, which is population, divided by area. Well, they don't want population density. You've got it. They're trying to figure out this number here. So if you remember from algebra, you multiply area to the top here, you'll get population density, but you got to multiply by area over there. So what we're looking for is population is equal to population density multiplied by area, okay, which is 365 times 63. The numbers are all given to you, which is nice. And when you're done, we will come out with 22,995 people. Okay? All right? So that's your populations. 22,995 persons, I guess, is more appropriate. All right? Good news is you don't have to round to anything here. Okay, the next one. We'll be asking, I believe, for density. Yep, population density, okay? So number 4, a county can be approximated by a rectangle. So anytime you see a figure and they give you two numbers, what do you think they're giving you? Your area, right? Okay, so the county, because if we're dealing, let's keep reading. The current population is 378,420. Based on this information, find the population density of this county. Round to the nearest whole number. Okay, so we're going to be able to use this formula straight up. Okay, so we're going to put population density, and this one will be on the board for you, divided by area. Okay, population is 378,420 people. Okay? And then you're going to divide that by area, and they gave that to you. It's 212 multiplied by 75. If you want to do that separately, you can. That's up to you. I came up with 15,900 on the bottom, so I'm going to do that. So we get 378,420 divided by 15,900. That's what 212 and 75 are. Okay, and your population density comes out to 23.8 people per mile. Now you never have a 0.8, and that's why that's why they have you round it to the nearest whole number. So let's do this one. We haven't really practiced this one a lot. But here's the whole number, okay? It's basically the decimal, the number before the decimal. Okay, sorry, I shouldn't have used that color. So it's 23.8, I'll just point. So we're looking at this number, and we have to look at the guy behind him. Is he greater than 5? Yes, he is. So that makes that 3 become a what? 4. So your answer is 24 people per mile squared. Okay? And that's population density. All right? So that's the answer for that one. 24 people per mile squared. All right, let's go on to number 5. It says a basketball has a mass, so I'm going to write it down, mass of 624 grams and a volume of 0.25 feet cubed. What is the density? Okay, so there will be a significant amount of reading tomorrow, but again, if you practice tonight, you will be fine. Okay, so we have, we need a formula, don't we? So do you guys remember that little trick? Anybody? Density, volume, and mass, and you divide if it's above, multiply if it's below. Okay, so I'm going to go over here, and I want density, so I need these two. So density, covering it with my finger, is mass divided by volume. And mass is 624 grams divided by 0.25 feet cubed. Okay, so the result is 2,496 grams per feet cubed. Okay, and it's not asking you to round or anything, so there's your answer. Okay, 2,496 grams per feet cubed. So all you have to do is grab those two numbers and divide. Okay, so let's go on to number 6. Now we can do the cube. This is a density problem, but it involves 2 steps. They're leading you to do first the volume, because if you recall, they're going to ask you, I'm kind of getting ahead, but B is to find what is the mass of the cube. Okay? So again, we'll use that fancy formula. Okay, so we have the density times volume on the bottom. That's how I remember it. I will have this one on the board for you, so don't worry about memorizing it. Okay? All right, so let's leave that alone. But just so you know, because I'm asking for the mass is equal to what from this formula? Cover the mass, what do you have to do? Density times volume. So if you look, they're going to give you the density right here, but what is it that's missing? The volume, and that's why they ask you in Part A to find it, okay? Well, all of you know that this is a rectangular prism, and the formula, and I'll make a little note, rectangular prism. Now on the gold sheets, I'm going to tell you it's a rectangular prism, but you're going to have to go look for that. Length times width times height, which is 6 times 6 times 6. Okay? All right. So that comes out to 216 centimeters cubed. 216 centimeters cubed. So we got one part. Okay, so at least get that part, at least get that credit. And then mass equals density times volume. So we get to just grab this number here and plug it in. 1.62 grams per centimeter cube multiplied by 216 centimeters cube is going to give you 300. Let's see if I could squeeze it in here. I'm going to move over here if you don't mind. It's 349.92, and the reason I'm doing that is because it's asking you to round to the nearest whole number. So again, what number am I going to look at to see if we're going to increase it or not? Is it the 3, 4, or 9? 9. So I'm putting an arrow there. Who am I going to look at? The guy behind him. Is he 5 or greater than 5? Greater. So what's going to happen to this number? 350. Okay? So 350 grams. And that's it. Mass. Okay? All right, so that's giving you some really good practice about rounding. Let's go on to the next part. This is GMD A.1. The previous one we did was MG A2 and GPE B7. I apologize, I didn't introduce these standards. Very important because you're graded on standards. Okay, I can explain the formula of the volume of cylinder, pyramid, cone using dissection, capillaries, and formal limit argument. 7. List 3 things that the solids shown below have in common. What's the first one? Radius is the same. What else? The height is the same. And what do you think is going to happen next? The volume. And what's the volume? If you want to get credit, put volume is pi r squared times h. Just go to the gold sheet and grab it. And it is the same for both. And that's what we call cavalieri principle. That's it. Okay? All right, number 8. We've been using in the past, remember the lemonade with the cones and the cylinders? Okay, so that problem could come out on the test, or this one. Now we're exposing you to both. This is the one where you say 3, remember? So Evan has a popcorn container in the shape of a square prism that can hold 360 cubic inches. He also has the same square pyramid shaped containers with it, and the key is same height and same length. Okay, so how many pyramid shapes, so how many of these do you think can fill up that guy? The answer is 3. Explain. Okay, so the square prism, okay, this is a square prism. The volume is length times width times height, so you're going to write that in. The pyramid is length times width times height divided by 3, so I know that that's a relationship. That there's 3 of these, which is the pyramid, that can fit in the prism. 3. Now, I did mention to you when we were going over this problem, we wouldn't have to worry about the 360, but we do. I apologize, we actually do. That's what this one's asking. How many cubic inches will the pyramid container hold. Okay, so we want to know if this one is 360 inches cubed, that's what cubic inches mean, okay, they want to know how much is in the square pyramid. So what do I do with 360? Yeah, divide it by 3, and you're going to get 120 inches cubed. Okay, so I'm just going to ask you to practice this probably 2 or 3 times just to get it, okay? All right. So, let's go to the back, number 9, okay? Complete the following table, and we are now on the second part, which should be the peach color. Everybody should be on the peach color now. Okay, so complete the following table, okay? And what I'm going to do here is go ahead and hit a pause.